Okay, so this is a June 2012 paper, and this is questions on projectiles. First part of the question you can see is describe projectile motion. Now you know projectile motion has both vertical and horizontal components. This question is worth 2 marks, so I need to say 2 things. And here I've just talked about, we know the vertical component is going to change due to acceleration to gravity action on it. So that's what I said. I said uniformly accelerated in vertical direction. So that's 1 mark. My second mark comes from talking about the horizontal component, and I've said it's a constant speed in the perpendicular horizontal direction. Because you know the speed horizontally does not change, stays constant throughout. Okay, so that is all you have to do, is just describe the motion. Next part of the question is a projectile lands at the same vertical height from which it's launched, 1.36 meters from the launch point after reaching a maximum height of 51. Show that the initial vertical component of velocity is 31.6. Right, so if we know, let's talk about maximum height, so that's obviously going to be our vertical distance. I'm going to symbol S. We need to prove this, so we can actually use it in the equation. But we know at maximum height, our final velocity, V, is equal to 0. And we know if something's going up, we know acceleration to gravity is going to be negative. It's going to be minus 9.81. So once we do that, we want to find U. We've got V, got A, and we've got S. So do we know an equation of motion that links U, V, A and S? Yes. V squared equals U squared plus 2AS. We need to rearrange it to get U. So at the minute, U is being squared. But the easiest part to get rid of is this. It's been added on to 2AS. So to get rid of that, we just take it away from both sides. So it's V squared minus 2AS equals U squared. And then to find U, we obviously just have to square root this. Now all I'm going to do is just put in my numbers. So V is 0, so V squared is also going to be 0, so I'm just putting in 0. Take away 2 times negative minus 9.81. Now remember, this minus and this minus will cancel each other out, so your answer will be positive. Multiply that by 51. And when you type that into your calculator, you should get U to be 31.6. Okay, so that's that proven. Next part, it says calculate the horizontal component of the velocity. So whenever we're looking at the horizontal component of projectiles, we use speed equals distance divided by time. Let's see what we know. So we know, don't need to use that vertical height. We know its horizontal distance travelled is 136. So my horizontal distance travelled is 136. Do we know a time? No. But it says here, the projectile lands at the same vertical height from which it is launched. Now remember, if you are throwing something in the air, and it lands back down the same sort of level from which it was thrown. To find the total time taken, we find the time to maximum height. And then to find the total time, we just multiply the time to maximum height, multiply it by 2. So that's what we're going to have to do first before we can actually work out the speed. So we're going to find the time to max height. Now again, because we're talking about maximum height, it's about our vertical components. So we're going to have to use equations of motion to find the time to max height. So we know, I'm going to use this now because we know it's correct. U is equal to 31.6. At max height, The vertical velocity is 0, so v is 0. It's going up, so a is equal to minus 9.81. We want to find t. Doing an equation that links u, v, a and t, yes, v is equal to u plus at. Just need to rearrange it to get t. So at the minute, at has been added on to u. To get rid of that add, we take it away from both sides. So v minus u is equal to at. Now t has been multiplied by a. If we want to get rid of that a, we have to divide it. So we divide it on this side, we have to divide it on this side. So it's v minus u over a equals t. So I put in my wee numbers. So v is 0. Take away 31.6. Divide that by my minus 9.81. And that is going to give me a time of 3.22. Now, if you went and used this time in this equation, you could still get the answer wrong, because remember, it's a total time. So that's our time to max height. Our total time equals time to, I'm going to write max height times that by 2. So it is 3.22 times by 2, 6.44. Now all we have to do is just simply put in, there's our distance, there's our total time to travel that distance, and you'll get your answer to be 21.1 meters per second.